background, I will talk a little bit about the Tinker view. So Docker is very nice to play around with different processes, with different software tools and projects on your laptop, because it's easy to spawn different containers, use different environments, like Holger said, like have Ubuntu in different versions, have CentOS in different versions, have any other Linux distribution on your fingertips. So what I will show is where my motivation comes from. So it was HPC in the box. There's one slide I will show about it, and then I will demo some stacks that I'm using quite heavily. So Consul, Elasticsearch, Log/Kibana, and the metric stack that I put together yesterday. Where I'm coming from, I'm working for Gaikai now. Gaikai might not ring a bell, but PlayStation Now does maybe. So Gaikai is a company behind PlayStation Now. We are doing video game streaming, and we are part of Sony. It was announced, so PlayStation Now was announced on CES last year. And what this basically is, it's like video streaming, like YouTube and Netflix, but more real time and with feedback. So if you have a controller in your hand, then this controller will send data to our servers and change the game. So you're basically running a real-time application on the cloud. So it's like the network of Netflix or YouTube, but with higher constraints. So it's quite fun to work with, and I worked there for 8 weeks now. And yeah, I really like it. How I get starting with Docker? This slide is from the last presentation. So I worked for Science and Computing, as it turns out, last 5 years or so. I moved away recently, and I did my bachelor thesis about InfiniBand monitoring. And what I wanted to do all the time was having a hello world for everything. I wanted to spin up an HPC cluster on my laptop. So having the Slurm cluster, having monitoring, having a scheduler and all of this on my little shiny laptop here. But I started using VirtualBox for this, and after a couple of virtual machines, as you can imagine, the laptop was completely screwed. So I put it aside a little while, and then I stumbled upon Docker, and this applied very good to my problem. So I have a lot of containers, basically virtual machines, on my laptop, and I'm able to run every stack I like on my little machine. Okay, so I containerized all the things, and the first thing I did, or the first component I'm using now heavily is Consul. Who's familiar with Consul? Good. Consul is basically the backbone of my Kniep terminal, which is a term for my container environment. It ties together service discovery, the DNS interface, health checks like Nagios, and is a key value store as well. And this is quite fun. I will give a short demo now. It fits perfectly for a microservice architecture, so you can have different containers on your system, and they all connected via Consul, and then you can discover new services, spawn in your cluster, and you can access information about them. And this we will see. Oh wait, one's back. And what Holger didn't show was compose. I think that's also a very important thing to know. So you can run Docker containers like this, as he has shown. So I spawn an Ubuntu node, but this is quite cumbersome. If you want to compose, or if you want to start a stack with different nodes that are linked together, then this becomes very, very hard to do, or very, very awkward to do, because you have to memorize the different names you give the different containers, and this is quite cumbersome. What is much easier is using Docker Compose. And Docker Compose is just a YAML file that presents the different Docker run commands and organizes this in a very much sane way. So the different sections here are basically the Docker run commands, and this Consul node, for instance, is the name of the Docker container that will be spawned just in a sec. The image, so it's self-descriptive, right? You have the image that you want to start, you have the ports that you want to map in the container, the host name, the DNS, and so on. And the second container links to the first container, which will introduce environment variables, and then you can react on these environment variables. If I now start this stack with docker compose up -d, this will start the two different servers here, or two different containers. If I do docker ps, you see, okay, I have two servers or two containers, one of which presents us the web interface of console, which is here. So I have two nodes, console and terminal. One has a console service, one has no service at all. And yeah, this is now my little simple stack composed of two servers. If I log into the terminal one, I can ask console to give me the members of the server or of the stack. I have two nodes, terminal console. One acts as a server, one acts as a client. I can ask him to give me the services running in the server. And yeah, this is pretty simple. If you play around with it a little bit more, it's pretty simple. I mean, it's some learning curve involved, but it solves a lot of problems for me. I just added some stupid services here. So this is how you describe services in console. It's basically like Nagios checks. So you have a name like IC0. I can provide some tags. I provide a port, and then I provide a check script. If the check script exits with 0, the return code is 0, then the service is considered okay. If it exits with 1, then it's considered warning. And if it exits with 2 or any other return code, it is returned out as critical. So I put down the JSON script in the console directory and reload console. And now if we go back to the console dashboard, we see that the terminal now has 3 different services. One is passing, one is warning, one is critical. And if I now use the same little script here, which curls just the RESTful API of console, we see that we have these 3 services here. And if I do another curl query, then I can see that I can query even the different services just like that. And since console provides a DNS interface, we can also use simple service, the service interface, and we can even use just simple DNS entries in our configuration files. So no hard coding of IP addresses anymore. You can just use the service DNS name for this. So far, questions? Okay, no questions, and I will kill this little stack and go to the next one. This is AELK. Someone knows the ELK stack? It's Elasticsearch Logstash Kibana, which is kind of the open source log analytics stack. Ah, okay. So the Docker Compose file looks quite similar in shape, but we have only one big fat container here. It's what Holger describes as system container, I think, because I have multiple processes in this big clunky container. If I start it, so this C up is just Docker compose up -d. It's an alias. And this starts one container with a lot more ports forwarded. And if I go and have a look at the console interface, we will see one node, which is still stabilizing, and we have a bunch of services that are provided by this big node. So now all the services are up and running. So if I click here, and what we got is we got a Logstash instance or Elasticsearch instance, which is a text indexing database, but I don't want to get into details here. The simple fact is that you can run or you can forward your logs to Logstash, and then you can tinker with the logs, like filtering them, applying rules and whatnot, and then it will end up in Elasticsearch, and with Kibana you have a nice interface to look at this as its logs. So if I go and log into this this container, I have syslog configured to forward all the logs to my Logstash instance. And if I do a log here, I see 2015, then this will end up in my Elasticsearch instance. And as you can imagine, this is pretty helpful. If you have a big cluster, you can use Logstash or similar services like Heka, for instance, or Fluent or whatnot, to streamline your log process. Okay, that's the ELK. Then just one more stack I would like to show. Who's using a Logstash, by the way? No one. You grab your log files? I mean, you should really check this out. This is pretty nice and pretty fancy. So this was one big. Oh, and I have slides as well. I mean, I can put this. This is one big clunky container here. So it's Log Analytics, Elasticsearch, Logstash, Kibana. It's a system container. It's more like a big virtual machine, and I think that's the first step that is natural to use Docker with. Use Docker. That you mimic what you know from virtual machines, and then you provide or you create one big container that has SSHD running, that has all the heavy services that you're running in the virtual machine as well. That's natural iterations or evolution on it. It feels more like one big virtual machine, and it contradicts the mantra of one process per container that Holger presented as well. I mean, it's ideal way of using Docker or Linux containers would be one process, but I think that's most likely not the case. The last stack I would like to present is metric stack. I use Carbon, InfluxDB, all the nice and shiny open source tools for metrics collection. And this is really a service container. So I have a main service that is running in one container. And it has also a console agent for connecting the console cluster and a syslog daemon to have natural logging facility inside of the container. And it's close to one process per container, even though I have this housekeeping services that I keep. Okay, so let's start this stack. It composes of a lot of containers, so console, Carbon, Graphite, API, Grafana, metrics. And if I spin this up, compose up -d, it starts them in the right order so that they can link together. And if we have a look at the console interface, we see them coming up, all services, all nodes. And we see that the relay, which has also a nice web interface, is now taking in metrics and forwards them to my Carbon instance. And by doing so, I can view all this metrics with Grafana, which is a nice JavaScript dashboard for metrics. And if we wait some time, then we can see all the metrics coming in. So this would be the Carbon backend. As front end, I have Grafana in the version 1.9. As a middleware, I have Graphite API, which just provides a RESTful API to all the metrics. And this is how it turns out. To put it one step further, I now start an InfluxDB instance, which links as well to the console server. So if I start this, then we will in a couple of seconds see that now we have another network metrics coming in. So InfluxDB obviously started. This is the InfluxDB web interface. And now we see that all the metrics are also not only stored as in the Carbon instance, but also in InfluxDB. And when I start another dashboard, I can compare both metric subsystems on my fingertips. So here we have Grafana 2, which is a nicer version of Grafana 1.9. I have the same dashboard that I provided for the Graphite backend here. So this is the same metrics. If we compare them, they look quite alike. And now that I have Influx, I can go to the InfluxDB backend and I see the same metrics with a different backend. Since I started just a couple of seconds ago, I don't have as much data, but that's obvious, right? So, yeah. And since I use Consul, and with Consul I can orchestrate my configuration, it automatically detects there is another metric sync for my metrics, and it provides, or it adds the second metrics backend to my relay, so that I can now send metrics to Carbon Relay NG, and it will automatically send the metrics to the right backend. And I can here use regular expressions to match different metrics and send them to different backends. InfluxDB, for those of you who don't know InfluxDB, it's a Go project, pretty recent one, or not that recent, maybe a year or so. But it's an in-memory database for time series data, which is kind of nice. Whereas Carbon is the default backend for the Graphite universe, and it uses an iteration of RRD tool files. So for every metric, you have one single file, which is kind of awkward if you have millions of different metrics and you don't want to deal with millions of files. So by using InfluxDB, you have a more sane way of having to deal with a lot of different metrics. Okay, so this is just a practical tipping my toe into what you can do with Docker in terms of stacks. I'm a little bit short on slides because I thought, okay, after the introduction, it would be nice to have some practical insights. And as I already knew that we have a dense workshop and we will be short on time, I limited myself to 15 minutes. So. That's basically it. Questions about this? Otherwise, we'll go to the next speaker. Please.
I saw that you were using the DNS-based API of Consul.
Yeah.
Do you have any thoughts of what the uses might be for using the DNS-based API? Because I have found none so far.
You mean like? You mean the dig command I used?
Yes.
With this, it's pretty natural to. So if I now dig for the service entries for my Carbon services, and I have two now, or metrics. I think it's metrics. I renamed it. Or is it Carbon? Oh, it's Carbon. So if I have multiple services, Consul automatically round robins the different services, and if you have different ports, it provides you easy access to this information as well. And I think there are a lot of tools, or since Unix has the capability of using DNS for everything, you can just put this Carbon service Consul DNS name into your configuration file, and then you do not care what IP address. If the IP address has changed, or if the service is down, or what have you, it's very easy and natural to use DNS in configuration files, as it's around for 30 years or so. And
yes. And so would it be use Consul, for instance, like a replacement for Pacemaker or other high availability tools?
Yeah, I'm not sure about Pacemaker, but I think there are a lot of replacements or a lot of services or a lot of orchestration work that you can do with Consul that you otherwise have to do with a lot of different tools that you have to plug together. Before Consul, I used etcd and SkyDNS, so I used different backends for orchestration, and I had to put a lot of ugly bash scripts in my containers to provide information which service is running and which is not. And here it's just as simple as putting a little JSON snippet into this folder, and it will provide the information directly via DNS or via RESTful API. And there are libraries for all the major languages which you can use to interact with this information. Or you can just curl the RESTful API as I showed in the first demo. So Consul for me, it's a very easy way to orchestrate and deal with different IP addresses in a very flexible environment, to say the least. Because if the service check determines that the service is critical, then it will kick it out of the interfaces. So you couldn't use it in DNS anymore. You couldn't use it in the curl interface anymore. So you do not have to care much about your service. If you stop the service, it automatically gets kicked out of the DNS round robin, and then everything is fine. So for me, it helps very, very much. And yeah, with containers, since it's a very little binary blob that you put there, you do not have any dependencies. You put the Consul is written in Go, obviously. You put the binary of Consul there, and then off you go.
Thanks.
Yeah, and to show the Consul configuration file is also JSON, so you can forward the DNS to Google or to any other DNS server. So if you ping Google here, it will act as a natural DNS server. So if you haven't checked out Consul, it's worth it, I promise, and it's quite fun because it's very easy to use. Okay, so kill everything. And then we can go on. I think Alex.